Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
Okay, so that is our introduction to our new unit. 9.4, you should have that note packet. Go ahead and take that out. 9.4 is all about vectors. So, just like it was stated in our introduction, a vector has both magnitude and direction. A scalar, however, only has a magnitude. So we know the size, but we don't know what direction. So let's look at these first 7 statements and determine if each one represents a vector or a scalar. Number 1, riding a bike 1 mile per minute. Well, because we don't know the direction, that would be a scalar quantity. Number 2, riding a bike 1 mile per minute due west. Now that I've included a direction, that becomes a vector. Number 3, a 20-pound child hanging on the monkey bars. Well, that would be a vector. And the reason why it's a vector is because we know that gravity, if you're hanging, gravity, you can only be going one direction, which is down. So number 3 would be a vector. Number 4, wind blowing at a speed of 3 miles per hour. So again, I don't know if the wind is blowing east or west, so that would be a scalar. Students running in the hallway. Take a guess. What do you think that would be? Well, I didn't say what direction they're running, so that would be a scalar. A car driving 65 miles per hour on a highway toward Chicago. Take a guess. If you said scalar, you are right. Because I didn't say if we were driving to Chicago from Indianapolis, from Michigan, from Arizona, from California. We don't know what direction we're coming from. We just know we're driving toward Chicago. We don't have a direction. We only have a magnitude. Wind blowing east, that's my key word, at a speed of 1 mile per hour. We have a direction, so that would be a vector. All right, moving on to page 2. There's a couple of formulas that we need to make sure you have in your notes. So in the corner there, you should have an area to write these formulas. And the first formula, the formula for magnitude, where it says formulas to know, the formula for magnitude is equal to the square root of the change in x squared plus the change in y squared. And our formula for direction, go ahead and make sure you, again, write that in that box to the right where it says formulas to know. Again, these are the formulas that will not be given to you on the test. That's why I put them in that box. Direction is the inverse tangent of the change in y over the change in x. So let's look at this first example here. We have a vector. We have vector PQ, which in order to notate that, the symbol for vector looks like half of an arrow. And we're going to figure out the magnitude and the direction of this vector. So I'm starting at P. So I'm going to label that X1 and Y1. And I'm ending at Q. So we'll call that X2 and Y2. So to find our delta, first we need to figure out what is our change in x for both of these, for both points. So delta x equals x2 minus x1, which would be 7 minus 1, which equals 6. Delta y equals y2 minus y1, which would be 6 minus 4, and that would be 2. So now that we have our change in x and our change in y, vector PQ can be written as, and again, something else, these pointed parentheses, we use that for vectors only. So it's not that, it's not that. It looks like a pointed V. It's a point. So vector PQ has a change in x of 6 and a change in y of 2. So that would be my vector. So let's find the magnitude. The magnitude, again, keeping in mind our formula, would be the square root of 6 squared plus 2 squared. And again, feel free to pause the recording at any time. But 6 squared plus 2 squared would equal the square root of 40, which simplifies down to 2 root 10. I would also accept that as a decimal. Now, when we talk about direction, we need to think about, if this is my change in x and change in y, what quadrant has a positive x and a positive y? That would be quadrant 1. So we know that this is Q1. And because it's Q1, our direction, which is theta, has to fall between 0 and 90 degrees. So let's see if we get an answer between 0 and 90 degrees. And we'll talk later about what to do when that doesn't happen. So my direction, which is theta, is going to equal the inverse tangent of the change in y, which we figured out was 2 over 6. And we're going to go out to the thousandths place. When you type that in your calculator, you should get 18.435. And that would be the magnitude. We got our magnitude of our vector. We have the direction that our vector is going. We have it written in vector notation. And this is actually called component form, because component form shows the change in x and the change in y. So for the rest of this page, we're just going to practice finding the magnitude and the direction for each vector. So let's look at A. A is already in vector form. Notice that we have our pointed parentheses. So I know that this is my delta x and this is delta y. So we can find our magnitude and our direction. So our magnitude would equal 5 squared plus negative 2 squared. Hopefully I don't need to remind you that when you put a negative in your calculator, if it's squared, you need to put parentheses around that. So I got the square root of 29. And if you were to type that in your calculator, let me see what we get real quick. So the square root of 29, you would get approximately 5.385. And our direction. So now let's talk about direction. What quadrant do you think has a positive x and a negative y? I'm going to give you a second to think about that. Positive x, negative y. All right, well, that would be in Q4. And in Q4, the angles have to fall between 270 and 360. So we need to keep that in mind as we find the direction of this vector. So we're going to take the inverse tangent. And it's always y over x. And when you type that in your calculator, I'm going to verify my answers because I already did it, but I want to make sure that I didn't mess it up. All right, yes. So I got a negative 21.801, which we know would technically be in quadrant 4. But when we are thinking about direction, we want it to be a positive angle. So I'm going to add 360 to that to ensure I get a direction that falls between 270 and 360. So when you add that 360, my final direction for theta would equal 338.199 degrees. All right, let's look at example B. So example B, they did not give us the component form. So we have to figure out what is our change in x and our change in y. So my initial is always x1 and y1. Terminal means where I end or what direction I'm going. It doesn't end, it just goes in that direction. That would be my x2 and y2. So let me start off by finding delta x. So that would be 3 minus negative 2, which gives me 5. And then my delta y, that would be 10 minus 6, which is 4. So the component form for this vector would be, I'm going to use my little pointed brackets, would be bracket 5, 4 bracket. So again, this is my delta x and my delta y. I'm going to challenge you now. Pause the recording and solve it for magnitude and direction using the formulas that we worked with at the beginning. All right, if you agree with what I got, I have a magnitude of 6.403, or you could also, I did not mean to put the degree symbol there. Let me take that off. So we have a magnitude of 6.403. or you can leave it as root 41, and our direction is 38.66. Now, I have a positive x, I have a positive delta x and a positive delta y, which means that I need a direction that falls somewhere in Q1. So my answer should be between 0 and 90 degrees. And that's what I got, so I don't need to add anything to it because we are within our range. All right, let's look at C and D. So notice in example C, we're using I and J. Just know that I, that is our symbol for delta X, and J, that's our delta Y. So when I write it in my vector, in my component form, my delta X is 3. And my delta Y is -4. All right, take a moment and try to find your magnitude and direction. So we know that a positive x and a -3, this would be in Q4. And theta should fall between 270 and 360. So again, -53.13 is in quadrant 4, but we want to write that in terms of a positive angle. So we're just going to add 360 to it. So when you do that, you should get that theta is actually 306 point, come on, pen, 0.87 degrees. So we have our magnitude and we also have our direction. All right, pause and do question D on your own. Okay. So if you typed it in correctly for your magnitude, you should have root 7, which is approximately 2.646. For your direction, you should have 40.893 degrees. But let's think about this for a second. Let's pause. We have both of our components are negative. Our delta X is negative and our delta Y is negative, which means that we're in Q3. Q3 is between 180 and 270. So what we actually have to do is our vector is here. We need to reflect that going here, which means I have to add 180 degrees. So this time I'm adding 180. Now, when you are doing your direction, you will only add 180 or 360. Those are the only two adjustments that you will need to make when you're finding your direction. So after I add that 180, I get 220.893 degrees. So again, we have our magnitude, and I also have my direction. All right, just a few more and then we will end there for today. Let's go to our next page, top of page 3. So at the top of page 3, we have some more formulas to know. So in that box where it says formulas to know, should be in the upper right corner of page 3. The next formulas that we need to memorize is that if you're trying to find delta x, so what this is showing, it says determine the horizontal and vertical components given that we have vector w and double lines. When you see a double line like that, that is the notation for magnitude. So what they're giving us this time is they're telling us the magnitude and the direction, and they want us to find the delta x, the change in x, and the change in y. Okay, so we're going backwards. Before we had change in x and change in y, we had to find magnitude and direction. Now we're going backwards. They're giving us the magnitude and the direction, and they want us to find delta x and delta y. The formulas are actually quite simple. In order to find your change in x, you're simply going to take your magnitude and multiply that by the cosine of your direction. Again, I'm abbreviating magnitude as MAG because that's a long word to write over and over again. And then for delta y, again, writing it in the formulas to know, we're still using magnitude. But as you know, y is sine, not cosine. So it would be the magnitude times the sine of our direction. So let's go ahead and find our components. So delta x, so 7 is my magnitude and 20 is my direction. So I'm going to type in my calculator, 7 cosine 20. See what you get. And then for delta y, we're typing in 7 sine 20. And we will just go out to the thousands place for both. I'm going to verify what I got before, make sure. 7 cosine 20, 7 sine 20. All right, yep, I got the right answer. So for my change in x, or my horizontal component, I got that it was 6.578, and my vertical component, when you type that in, you get 2.394. So now let's write that in our component form. And component form simply means that we have those pointy well, they're not parentheses, but pointed parentheses. So I have my change in x. X always comes before y. And everything we do comes before y in the alphabet, comes before y in anything dealing with math. So that would be my final answer. All right, last example is example 3, and then we will end there for today. Same thing, we have finding your horizontal and vertical components given the magnitude. Again, I have a magnitude and I have direction. Pause the recording and find them and see if we get the same thing. And that would be all. Okay, so looking at the homework 17, you can right now, if you want to get a jump start on the homework, for homework 17, you can do 1, 3, and 4. So if you want to get a jump start, you can work on those 3 questions.